Hello my friends and welcome back to the You Can Do TV channel. At Altos Hornos de Mexico, steel production begins with the extraction of iron ore and coal from company-owned mines. The ore is transported as sludge through a 180-mile pipeline to the pelletizing plant, where it is filtered, mixed with binders, and formed into small pellets. These are heat-hardened at 1,300 degrees Celsius, preparing them for the blast furnace. Simultaneously, metallurgical coal is processed in vertical coke ovens, where it undergoes an 18-hour coking cycle. The resulting coke serves as the primary fuel for the blast furnaces. Additional inputs include sinter, a porous mix of ore fines, lime, and dolomite prepared in a continuous oven. In the blast furnace, alternating layers of pellets, coke, limestone, and dolomite are charged from the top. Hot air is injected at the base under pressure, creating temperatures up to 1,650 degrees Celsius. This reduces the iron ore into molten pig iron, which is collected in torpedo ladles. Sulfur content is removed using calcium carbide and magnesium reagents, while slag is cooled and stored as a byproduct. Pig iron is converted into steel through two main processes, the basic oxygen furnace, BOF, and the electric arc furnace, EAF. In the BOF, oxygen and inert gases are injected into a mix of scrap and pig iron inside a refractory-lined converter. In the EAF, scrap and iron are melted using graphite electrodes, delivering up to 140 megavolts. Refined liquid steel undergoes secondary metallurgy, degassing, and alloy adjustment before being cast into slabs. These are processed through hot and cold rolling lines, producing coils, plates, structural profiles, and tin-coated steel. The entire operation is powered by in-house utilities and adheres to strict quality, safety, and environmental standards, delivering industrial steel to exacting specifications. A terrifying moment unfolds in the steel mill. A violent explosion rips through the electric arc furnace during slag removal. Caught on surveillance cameras, the blast erupts suddenly, first from the top of the furnace, then violently from beneath. In just a split second, what seems like routine scarifica turns into chaos. The cause? Likely moisture or trapped water hidden beneath the slag, instantly vaporizing into high-pressure steam the moment it contacts the molten steel. The furnace convulses, fire and gas erupt outward, and molten metal sprays with terrifying force. It's a brutal reminder of the raw, untamed energy inside every EAF. Even the smallest oversight, wet scrap, residual water, can trigger a catastrophic chain reaction. For workers, it's not just steel they're handling. It's pressure, heat, and danger, every moment demanding absolute precision and caution.
In the CBE series of crusher buckets, quality is forged, literally. At Cymex, excellence is not merely defined by ISO 9001 certification or the reputation earned in the field, but by deliberate engineering and manufacturing choices that ensure unmatched durability and performance. Every component is part of a precise chain of quality, beginning at the design stage and culminating in the finished product. This commitment extends to the meticulous selection of materials, suppliers, and production techniques. A prime example lies in the shafts of the CBE crusher buckets. These critical components are first produced through forging, a process that aligns the metal's grain structure to maximize strength. They are then precision machined on CNC equipment, achieving exact dimensional tolerances and surface finishes required for optimal operation. This dual process, hot forging followed by cold CNC machining, not only enhances hardness, but also delivers exceptional resistance to fatigue and wear. These shafts must withstand extreme dynamic stresses, including torsional and shear forces, as well as the constant abrasive action of stone, concrete, and rubble processed by the crusher. The result is a component capable of enduring prolonged heavy-duty use without compromising performance or reliability. By integrating advanced metallurgical processes with rigorous quality control, the Cymex CBE series ensures that every bucket delivers consistent crushing efficiency, extended service life, and lower maintenance demands, qualities that make these tools a dependable choice for demanding demolition, recycling, and quarrying applications.
Metal casting remains one of the most advanced and indispensable manufacturing methods in modern industry. At its core, the process begins with engineering design and ends with a fully functional component for sectors such as automotive, aerospace, energy, and maritime. The casting sequence starts with the transformation of customer-provided component drawings into optimized raw part models using 3D CAD software. These models consider shrinkage allowances, machining tolerances, core placements, and gating system design. In the sand casting process, synthetic resin-bonded quartz sand is used to create the mold cavity. Two-part wooden or metallic models serve as templates to shape the sand molds. A release agent is applied to the model, then molding sand is packed and compacted layer by layer using mechanical rammers. For prototype or low-volume parts, manual molding is preferred, while large series production employs automated molding machines. Cores define internal cavities or complex undercuts in the casting. These are manufactured in dedicated core-making departments using cold box, hot box, or furan resin systems. The core boxes are precision machined and dimensionally controlled. Once filled, the binder curing process is initiated either through gas, amine catalysts, heat, or air hardening. After ejection, the cores are coated with refractory ceramic slurries to increase surface quality and resist erosion from molten metal. In heavy casting applications, such as wind turbine hubs, diesel engine blocks, or ship components, the core weight can exceed 6 tons. Reinforcement rods and lifting brackets are embedded during core manufacture. Cores and mold halves are assembled in large steel mold frames and aligned using dowel pins to ensure high positional accuracy. The melting process uses cupola, electric arc, or induction furnaces, depending on alloy type. In ductile iron casting, molten iron is treated with magnesium to transform graphite from flake to nodular structure, enhancing tensile strength and elongation. The treatment occurs in converter ladles, where magnesium ferrosilicon is introduced under cover slag. The process produces a bright flare as magnesium reacts. After treatment, the melt is deslagged using aluminosilicate flux and filtered through ceramic strainers to capture non-metallic inclusions. The molten alloy, typically at 1370 to 1450 degrees Celsius, is then poured into the mold through a carefully designed gating system, ensuring laminar flow and even cavity filling. In high-volume cells, automatic pouring systems with thermal control ensure consistent metal temperature and flow rates. Cooling time depends on casting mass and section thickness. For components like turbine hubs, solidification can take up to 72 hours. Once cooled to safe handling temperatures, molds are disassembled using vibration tables. The sand is reclaimed, and cores disintegrate for removal. Gating and feeder systems are cut off, and castings are moved to fettling lines. Mechanical cleaning begins with abrasive blasting using stainless steel shot or corundum grit. Robotic grinding systems remove flash and risers, ensuring dimensional conformity. Castings proceed to inspection stations for non-destructive testing, including ultrasonic, X-ray, and dye-penetrant methods. Metallurgical quality is confirmed through spectrographic analysis. Samples taken from the melt are analyzed in real time to verify chemical composition. Microstructure is examined under a microscope after etching polished sections. For mechanical validation, tensile bars are cast integrally and tested on universal machines for strength, yield, and elongation values. Advanced manufacturing includes hybrid casting techniques. The insert is first coated and preheated, then placed in the die cavity. The magnesium is injected at speeds of 30 to 90 meters per second, under pressures up to 1,200 bars, creating metallurgical bonds between dissimilar metals. This enables lightweight crankcases for automotive engines. Die casting for serial parts uses cold or hot chamber processes. In cold chamber machines, aluminum or magnesium is ladled into a dosing sleeve and then hydraulically injected into the die. Mold temperatures and cycle times are tightly controlled. Cycle durations are under 1 minute, allowing efficient mass production of thin-walled parts with high dimensional precision. Across all operations, digital integration supports traceability and control. Automated mold lines, robotic core handling, and real-time monitoring ensure that technical specifications are met with minimal human intervention. Industrial robots perform tasks from pouring to trimming, while sensors provide feedback on mold filling, temperature, and mold alignment. Modern foundries like PowerGus represent a convergence of mechanical engineering, materials, science, and automation. Their ability to produce safety-critical, high-performance components relies on mastery of technical casting processes, from simulation and core making to melt treatment and final machining. From raw steel to precision tools, witness the craftsmanship behind every wrench. At Vishal Tools and Forgings, decades of expertise meet cutting-edge technology to produce millions of durable hand tools trusted worldwide. Here's how each combination wrench is forged, machined, tested, and finished to perfection. Located in Punjab, India, Vishal Tools and Forgings has been manufacturing hand tools for over 25 years, operating 2 ISO-certified units with a capacity of 2.5 million pieces per month. The process begins with CAD CAM product design, followed by forging die manufacturing using CNC and EDM machines to ensure micron-level precision. Raw materials, specifically chrome vanadium steel, are tested for composition. After approval, long steel flats are cut into blanks using a mechanical press. These are then heated to 1,100 degrees Celsius in a forging furnace and formed into wrench shapes with a drop hammer. Post-forging, excess material is removed via trimming and punching. In the machining phase, broaching shapes the wrench's jaws with tolerances of 10 to 20 microns. Broaches are made in-house, ground, and tested using micrometers and plug gauges. Next is heat treatment, where wrenches are hardened, quenched, and tempered in an electric furnace. Each batch is hardness tested, followed by a torque test to verify mechanical strength. Shot blasting removes oxidation, while PLC-controlled polishing machines and rotary polishers refine the surfaces. A vibrator polishing process smoothens the surface with abrasive stones and chemicals. Then, electroplating applies a corrosion-resistant nickel-chrome layer. Coating thickness and salt spray tests validate durability. Each wrench undergoes final visual and dimensional inspections before packing per customer requirements. Laser marking, cartonizing, and pre-dispatch inspections are conducted. For export, slip sheet systems replace wooden pallets, saving weight and increasing space efficiency. This precise, vertically integrated process ensures high-quality, globally exported tools, ready for demanding industrial use.
Trooper Corporation, a Mexican company with nearly 60 years in the hardware market, operates its main industrial complex in Jilotepec. This facility spans over 250,000 square meters and houses 12 industrial plants, employing 8,000 people globally. The complex manufactures approximately 45% of its 9,000 product catalog, including steel bars forged into tools such as hammers, axes, and shovels, using advanced forging presses and CNC mold fabrication. Energy-efficient manufacturing processes are applied throughout. The plant produces up to 10 million shovels and 11,000 wheelbarrows daily, making it a world leader. The Advanced Quality Center conducts extensive product testing across 17 laboratories, ensuring high standards. Nemagar specializes in the production of high-quality aluminum automotive components using advanced casting technologies. The work process begins with the design and engineering phase, where components such as engine blocks and transmission housings are developed to meet precise specifications for performance and durability. The manufacturing process uses state-of-the-art die casting techniques, ensuring high dimensional accuracy and excellent mechanical properties. Molten aluminum alloys are carefully melted and poured into precision molds under controlled conditions. This process includes automated handling systems to maintain consistency and reduce human error. After casting, components undergo rigorous heat treatment to enhance strength and resistance to wear. Following heat treatment, machining operations are performed using CNC equipment to achieve exact tolerances and surface finishes required by automotive standards. Quality control is integral throughout the process. Spectrometric analysis verifies alloy composition, while metallographic inspections and dimensional checks ensure each part meets strict criteria. Final products undergo functional testing to simulate real operating conditions. Nemak Gyor's products include engine blocks, cylinder heads, and structural components designed for lightweight performance and reliability. These components are supplied globally to automotive manufacturers, supporting efficient engine operation and vehicle safety. The precision investment casting process at Blank involves a series of carefully controlled technical steps to ensure high-quality metal parts with complex geometries and tight tolerances. It begins with the design and production of wax patterns, which are created using aluminum molds to achieve dimensional accuracy within plus or minus 0.03 millimeters. These wax patterns are assembled automatically by 6-axis robots into clusters called trees, weighing up to 35 kilograms, with continuous quality monitoring via camera systems. Next, the wax assemblies undergo multiple coatings with ceramic slurry under strict control of temperature and viscosity to build a robust ceramic shell approximately 8 millimeters thick. This shell provides the mold's structure and must withstand the high pressures during metal casting. Following this, the wax is removed through a steam autoclave process, leaving a hollow ceramic mold. The ceramic shells are then fired at around 1050 degrees Celsius to harden and stabilize the mold. Molten metal is poured into the hot ceramic mold using vacuum or low-pressure casting methods, which minimizes gas entrapment and defects, ensuring excellent metal integrity. After solidification and cooling, the ceramic shell is removed by automated robotic systems and water jet cutting. The raw cast parts proceed to CNC machining centers with 5-axis capability to achieve final dimensional precision. Non-destructive testing methods such as 3D scanning, X-ray, and ultrasonic inspections are performed to detect internal defects. Finally, the parts undergo vacuum heat treatment to optimize mechanical properties and hardness. Strict quality control ensures all specifications are met before the parts are packed and delivered using just-in-time logistics. This comprehensive technical process allows Blank to produce complex, high-performance castings used in automotive, aerospace, and industrial applications worldwide. Zollern's vertically integrated Lacherthal plant melts duplex, nickel-base, and copper-aluminium alloys in 4T induction furnaces, vacuum degassing and confirming chemistry via real-time spectrometry. Metal flows into 3 routes: centrifugal casting in 1,500 revolutions per minute copper molds for seamless rings with 1% wall variance, furan-bonded sand molds, magma-soft optimized, bottom poured through ceramic filters for housings up to 15T, and lost wax shells de-waxed at 9 bars, poured under 10 squared MBAR vacuum yielding porosity-free turbo wheels. Post-cast, robotic knockout, water jet gate removal, and 8-zone heat treatment, plus or minus 5 degrees Celsius, proceed 5-axis CNC finishing and ring rolling to E4 meters. Digital X-ray, phased array UT, and metallography certify every component.
Manan Shahid Forgings Limited, MSF, based in Lahore, Pakistan, is the country's largest and most advanced forging house, with 2 dedicated forging units and 1 machining plant operating in close proximity. Established in 1974 as a small forge shop with an annual output of just 250 tons for railway and gas industries, MSF quickly expanded and pioneered automotive forging in Pakistan. Today, MSF is a key OEM supplier to domestic brands such as Massey Ferguson and Atlas Honda, while nearly 40% of its production is exported globally to renowned international clients. The production cycle begins with stringent inspection of over 30 types of raw steel to meet precise metallurgical and mechanical specifications. Once approved, the steel is sheared and heated to 1,250 degrees Celsius in induction furnaces. Forging is followed by trimming and hot coining. All forging dies are produced in-house, using CAD CAM systems and CNC machining for maximum precision. Post-forging processes include normalization or isothermal annealing in gas-fired furnaces, followed by salt bath hardening to maintain temperature accuracy. Shot blasting removes scale, while magnetic particle inspection ensures all parts are crack-free. Components requiring further processing are sent to the machining plant, equipped with CNC turning, hobbing, milling, drilling, and grinding. Induction hardening of axles and spindles is also performed. A CNC coordinate measuring machine ensures dimensional accuracy before final inspection. Components are degreased, treated for corrosion prevention, and packed using VCI materials for safe storage and shipment. MSF maintains process integrity and product excellence through robust in-house quality assurance and technical expertise built over decades.
Tapered roller bearings are precision-engineered components designed to manage both radial and axial loads with exceptional efficiency. Their distinctive design features conical rollers positioned between an inner race, known as the cone, and an outer race, called the cup. This geometry allows the bearing to accommodate combined loads and transmit forces smoothly along the roller axis. The tapered shape ensures that the roller's contact line meets at a single point on the bearing axis, minimizing friction and distributing stress evenly across the rolling elements. This design not only enhances load capacity, but also extends service life, even under heavy-duty operating conditions. Manufacturing these bearings involves precision machining and heat treatment. High-grade bearing steel is forged and turned to exact tolerances. Surfaces are then ground and super-finished to achieve the low roughness necessary for smooth rolling motion. Heat treatment improves hardness, wear resistance, and dimensional stability, ensuring performance in demanding applications. Tapered roller bearings are available in single-row, double-row, and four-row configurations. Single-row designs handle radial loads and thrust loads in one direction, while double-row and four-row versions support higher radial loads and thrust forces in both directions. Common applications include automotive wheel hubs, gearboxes, industrial gear drives, steel mills, and mining equipment where durability and precision are critical. Lubrication is essential to their operation, reducing wear and preventing overheating. Bearings may be lubricated with grease or oil, depending on the speed, load, and environment. Proper installation, preload adjustment, and maintenance are key to maximizing performance and preventing premature failure. From heavy industry to everyday vehicles, tapered roller bearings play a vital role in keeping machinery moving reliably, offering the perfect balance of strength, precision, and efficiency. Electropolishing's process begins with thorough pre-cleaning, including descaling and pickling of stainless steel parts. Components then undergo high-volume electropolishing across 12 dedicated lines designed for various stainless steel grades, 300 and 400 series. Throughout the process, strict visual inspections and quality controls ensure surface finish consistency. Finished parts are carefully handled and packaged to maintain quality until delivery.
Lingbo Nide Mechanical Equipment Company Limited specializes in automated solutions for electric motor manufacturing. In the production of a washing machine motor armature, the process begins with shaft insertion into the laminated iron core, followed by precise balancing to ensure stable operation. Next, the coil winding machine wraps copper wire around the armature slots with high accuracy, using either flyer or needle winding technology, depending on the motor design. After winding, wedge inserting machines push insulating wedges into each slot to secure the windings. The commutator is then assembled onto the shaft and tightly pressed. Using spot welding, the wire ends are connected to the commutator bars. This is followed by a varnishing process, where the armature is dipped or trickle-coated with insulating resin, then cured in an oven for thermal stability. A dynamic balancing machine adjusts mass distribution to minimize vibration. Finally, the finished armature undergoes electrical testing to verify insulation resistance, surge, and high-voltage performance before assembly. NIDE provides fully or semi-automated lines tailored to customer needs, ensuring consistent quality and production efficiency. From winding to testing, every step is optimized for reliability in washing machine motor armature manufacturing. At Continental's Nuremberg plant, the production of innovative 48-volt electric motors is optimized for high-volume output. A modular manufacturing concept enables flexibility to produce various motor types tailored to different customer needs and global markets. One key innovation is the stator, formed by inserting copper rods into a carrier and joining them with precision laser welding. The stator is fitted into the motor housing using a shrinking process, creating a tight, durable bond. Advanced automation, including collaborative robots, ensures seamless integration of all steps. Continental also manufactures open semiconductors directly on ceramic substrates, enhancing inverter performance. The result is a compact 48-volt unit that replaces starter and alternator functions, offering high efficiency and power density.
Mayana supplies an end-to-end solution for stamped metal components, beginning with customer-supplied CAD models. Engineering teams perform DFM studies, create strip layouts, and run finite element simulations to forecast thinning and springback. Progressive, transfer, or tandem dies are then designed and manufactured in-house using high-speed CNC milling, wire EDM, and laser hardening, achieving die tolerances within plus or minus 0.01 millimeters. Production employs 200 to 1,000 ton mechanical presses equipped with electronic roll feeders and in-die sensors that track forming force and part ejection each stroke. Robotic MIG and spot welding cells assemble subcomponents, while vision systems confirm weld nugget integrity. Operations comply with IATF 16949, ensuring APQP, PPAP, and full traceability. The Nargisa MX700 hydraulic ironworker serves as a multifunction production center, uniting 700 kilonewtons punch force, 160 millimeters guided ram stroke, and a 350 millimeter throat within a rigid monoblock frame that preserves plus or minus 0.05 millimeters positional repeatability. Its 600 times 350 millimeters slotted table, featuring a central evacuation port, supports quick fixture change while channeling scrap clear of the work zone. Tooling is secured by a single M30 retaining nut and universal shank adapter, enabling operators to swap dies in less than 2 minutes and move seamlessly between punching, shearing, folding, and notching tasks. Setup begins in manual jog. The die is threaded into the bolster, the punch clamped in its holder, and the ram lowered until exactly 2 millimeters of punch enters the die, preventing edge chipping. Upper and lower limit switches are then stored. Automatic mode cycles between these limits, with an electronic counter-recording hits for preventative maintenance. Standard punch sets perforate 3 to 40 millimeters holes in plate, tube, angle, UPN, or IPN, while extractor plates matched to punch diameter eliminate deformation. Lubrication every 200 strokes extends tool life, and the punch diameter is always selected larger than workpiece thickness to avert breakage. A ventilation grid cassette produces staggered slot patterns, guided by stops that repeat to 0.1 millimeters, ideal for HVAC panels. Dedicated V-block tooling notches, angle sections flush to the web, and shears flat bar at 90 degrees. Add-on lateral guides allow identical cassettes to deliver precise 45 degrees miters for frame fabrication. Two folding modules expand capability. A 170 mm block with dual V openings, 56 mm for 6 to 15 mm plate, 26 mm for 0.5 to 5 mm sheet, and a 300 mm block offering radii for stock up to 20 mm thick, both producing closed bends unattainable on conventional press brakes. Pipe notching tooling completes saddle cuts in 2 strokes, profile punch, then swage, preparing tubes for 90 degrees T-welds or telescopic joints. The vertical guillotine slices sheet and handrail from 0.5 to 20 mm thickness over 200 mm length. Twin jacking screws with lock nuts tune blade clearance for burr-free results. Round bar shear knives handle EU 35 mm mild or stainless rod in a single pass. Custom dies, supplied to Ford, Nissan, and numerous SMEs, flatten tube ends for hinge knuckles, form ornamental arrowheads, radius plate corners, or punch multi-shaped clusters, all fitting the standard adapter. Safety is governed by an interlocked polycarbonate shield. With the red key light active, the guard may remain open for tooling alignment. Otherwise, the RAM energizes only when the screen is lowered. Robust construction, rapid tool change, and broad application range make the MX700 an indispensable asset for fabrication shops seeking high versatility in a compact footprint. In high-performance industries, turbine blades demand precision and efficiency like no other. Enter the M50GMILLTURN, a multifunctional powerhouse from WFL. This 5-axis machining center handles turning, milling, drilling, and more in a single setup, ideal for complex aerospace alloys. Raw components are clamped between the main and counter spindles, enabling perfect synchronous motion with no speed limits. Up to 14 tools, fully automated, perform roughing through to deburring with unwavering cutting forces. Ultra-high pressure coolant, up to 350 bars, is fed through the spindle, cutting machining times and tool wear. The result? Flawless turbine blades, machined precisely in one go, with outstanding consistency, surface quality, and cost efficiency. Doosan's Puma SMX 5100 is a dual-spindle, mill-turn multitasking center engineered for large, complex parts. A monolithic cast-iron frame with boxway slides and plus or minus 160 mm Y-axis ensures maximum rigidity and thermal stability. The main spindle delivers 26 kilowatts at 3,800 revolutions per minute, while the 12,000 revolutions per minute B-axis milling spindle and 0.9S servo tool changer enable complete machining in one setup.
At Mendy Group, the GURUTZPEGSM16 multitasking turn mill represents a benchmark in large part machining. Designed for high-performance applications, this machine integrates turning, milling, and boring operations with full 5-axis capability. It supports components up to E1,600 mm in diameter, 10 meters in length, and 20 tons in weight. Advanced technologies are implemented throughout the GSM series, GSM-10, GSM-13, and GSM-16, ensuring optimal performance for industries demanding precision and versatility. The machine delivers a high level of automation, allowing complete part machining in a single setup, which reduces downtime and increases throughput. Swing over the carriage and steadies matches the bed capacity, only limited by the rear wall. The X-axis stroke is optimized for tools up to 200 mm in length, enabling efficient access and stability during heavy-duty machining. With symmetrical design and thermal stability, the GSM-16 ensures accuracy over extended operations. The multitasking platform is ideal for complex workpieces in energy, aerospace, and industrial sectors, meeting stringent tolerances and finishing requirements. At Mendy Group, the GSM-16 enhances production capability with state-of-the-art machining, combining rigidity, precision, and flexibility in one robust system engineered by GURUTZPE.
The Gicamil are gantry-type milling center machines, rail switch points, and frogs in one setup. Its patented head indexes to 38 positions at 5 degrees increments, then transitions to continuous 4-axis interpolation across plus or minus 90 degrees pitch. A 30-kilowatt spindle and dual ball screw gantry assure 0.02 mm positional repeatability on 12 meters rails.
PrimeServe Hamburg is one of 100 global PrimeServe hubs, specializing in the repair and reconditioning of engine components. Key operations include grinding crankshaft radii, crack testing pistons, and welding piston crowns. The facility features advanced machining centers for overhauling components like cooling jackets and counterweights. Laser welding enables precise, low-distortion repairs. Crankshaft repair and manufacturing are core services, with tailored pipe connections and specialized tools used to reduce the extent of crankshaft damage without engine disassembly. Each task is performed with precision to ensure durability and performance, supporting marine and industrial customers with reliable, high-quality engine service.
Hanshin Diesel machines marine crankshafts through a closed-loop NC sequence that guarantees micron-grade tolerances. After ultrasonic inspection, the 7 meters forging enters a dual-spindle CNC roughing lathe that skims journals and crank pins to a plus 0.30 millimeters envelope. The shaft then rides inline rails to a dedicated crank pin lathe, where inner widths are finished while maintaining 0.02 millimeters / 100 millimeters squareness and 80% blue bar contact. Halbite cutters execute the final cut, producing micron-scale chips. Onboard piezo sensors modulate feed for consistent load. Handstone lapping elevates surface roughness to raw, is less than or equal to 0.2 micrometers. A vertical machining center drills the flange bolt circle, followed by in-house chamfering. Air gauge sizing and laser runout mapping certify every shaft prior to marine engine assembly.
Service for Wind Energy and Motion offers comprehensive solutions for drivetrain maintenance and repair, focusing on ZF and multi-brand gearboxes. With over 125 years of expertise in gearbox technology, the service covers turbines ranging from 0.8 to 9.5 megawatts. The process begins with careful disassembly, followed by the reworking and precision measuring of gears, housings, and planet carriers. Casting components are restored to optimal condition. Advanced solutions for both repairs and upgrades ensure maximum reliability. After reassembly, each gearbox undergoes a rigorous test run to validate performance. Final steps include painting, outbound inspection, and secure delivery to the customer. ensuring top-quality service at every stage.
Torque Marine Diesel executed a factory-spec zero-hour overhaul on the MTU-16V 2000M91 from a Lazara 116 yacht. Borescope and soap tests flagged liner scoring and iron greater than 85 ppm, prompting full teardown. On a hydraulic rotisserie, the 90 degrees V-block was stripped. The crankshaft was magnaflux checked, micro-polished, and refitted with grade C bearings after journals showed less than 0.01 mm taper. Cylinders received new end-plated wet liners, forged pistons, and chrome ceramic rings gapped at 0.35 mm, restoring compression integrity. Fuel hardware was renewed end-to-end. Dual filters, high-pressure pumps, stainless leak-offs, and 16 flow-matched injectors, certified at 1,600 bars. Each K36-21 turbocharger gained a fresh CHRA and dynamic balance less than 3 mg cm. Charge air coolers were acid descaled, hydro-tested, and re-zinc coated. Lube oil and seawater heat exchangers were retubed, while the raw water pump received a bronze impeller and ceramic seal. Valve train upgrades included sodium-filled exhaust valves, nitrated guides, and laser-hardened cam lobes. ECU 7.2 firmware was flashed and calibrated via MTU Diag, aligning CAN parameters with the yacht's Blue Vision network. A 3-hour dock load trial at 1,800 revolutions per minute confirmed exhaust spread is less than or equal to 6 degrees Celsius and vibration less than 6 millimeters per second RMS. ABS surveyors approved, and Torque Marine issued a 5-year warranty projecting greater than 15,000 service hours.
The Master G8 812 engine is a powerful, reliable, and fuel-efficient internal combustion engine, meticulously assembled by specialists at Gamma Energetica in their dedicated engine assembly facility. Unlike standard automotive engines, the G8 812 is specially adapted for use in gas-powered generator sets. These industrial gas engines, ranging from 60 to 200 kilowatts, are designed for integration into power units and generator stations. Each engine undergoes manual assembly, ensuring high build quality and extended operational life. All components are inspected, defects eliminated, and the engine is cold and hot tested before final assembly.
Ferrero's La Jolla Operations Complex, Arequipa's 50,000 square meters hub, integrates a world-standard component repair center engineered to process 3,000 assets yearly. Robotic welding, CNC machining, and dynamometer cells restore 400T powertrains. Ferreros's certified Caterpillar rebuild converts a high-hour Cat D8T track-type tractor to near-new condition through a structured sequence in its Lima machine shop. After a full wash and fluid analysis, technicians strip the machine to its bare frame. Critical steel structures undergo crack inspection, and the undercarriage is laser measured for wear. Any frame defects are weld repaired and stress relieved before components move to specialized overhaul cells. The diesel engine receives fresh cylinder packs, calibrated injectors, balanced turbochargers, and pressure-tested cooling circuits. Power shift transmission clutch packs are relined, control valves recalibrated, and steering planetaries fitted with new gears and bearings. Implement hydraulic pumps are bench-flowed, and control valves lapped for precise sealing. The undercarriage is rebuilt with sealed and lubricated links, new shoes, and hardened sprocket segments. Electronic modules load the latest software, while wiring harnesses undergo insulation resistance checks. Surface preparation includes phosphate washing and a 2-part urethane topcoat for long-term corrosion protection. Reassembly follows an electronic torque turn chart. Each fastening step is logged to the product link system for traceability. The rebuilt tractor completes bench tests, replicating maximum drawbar and implement loads. Only after meeting factory performance targets does Ferreros issue the Caterpillar Gold Seal certificate, resetting the machine's service hours and delivering a life extension package that costs a fraction of purchasing new iron. Throughout the rebuild, Ferreros applies Caterpillar's contamination control protocols. Sealed clean rooms for hydraulic assemblies, color-coded lubricant zones, and particle count verification before final fill. An ISO-audited quality gate captures dimensional reports, pressure traces, and thermographic images, all archived in the machine's digital service record. This documentation supports warranty compliance and facilitates predictive maintenance analytics for the owner. The Caterpillar's Certified Rebuild (CCR) process for the CAT 14H motor grader at Ferreros Machine Workshop is a comprehensive overhaul that restores equipment to like-new condition, extending its lifespan at a significantly lower cost than a new machine. Conducted in Caterpillar's 5-star certified workshops, the process begins with general disassembly, where every component is meticulously dismantled, inspected, and evaluated. Worn or defective parts are replaced with genuine CAT components, meeting stringent quality standards. The rebuild encompasses critical systems, including the engine, transmission, hydraulics, and structure, while incorporating engineering updates to enhance availability, performance, and durability. Following reconstruction, general assembly ensures the machine is fully functional and efficient. The process concludes with rigorous testing, and the machine receives a 12-month warranty, a new serial number, and a PIN for major components. Ideal for mining and construction, this certified rebuild maximizes equipment longevity, reduces operational costs, ensures compliance with safety standards, and maintains fleet consistency, delivering exceptional productivity and reliability. Komatsu's HD 1500 rigid frame haul truck targets 150T payloads with a 1,149 kilowatts Tier 4 F140E engine, driving an AC electric propulsion system. The alternator feeds dual inverter wheel motors, delivering 1,740 kilowatts retard capacity and 20% gradability at 14 kilometers per hour. A Z-bar hydraulically actuated McPherson strut front suspension and trailing arm rear isolate 27 Hz body vibration, protecting structures. The CommVision 360 camera radar suite, ABS/ATC, and automatic retard speed control maintain stability on declines. Frame life is greater than or equal to 60,000 H is achieved via low alloy, high toughness castings, and robot welded box section spars. Mina Justa marks a new mining milestone, a mobile fleet exceeding 50 Caterpillar units, headlined by 26 x 793D rigid frame haul trucks, each rated for 250-ton payloads, arrives on site. Integrated MineStar Command, high-wall auto-spotting, and terrain-adaptive payload control will underpin high-volume copper production, while Ferreros on-site support ensures 92% mechanical availability across loading, hauling, and auxiliary CAT assets. Ferreros has completed the mining industry's first dealer-executed major overhaul of a Caterpillar 7495 electric rope shovel, restoring Unit 495BI in Peru after an intensive 100,000-hour duty cycle. The project, delivered entirely by the CAT dealer's personnel, entailed 24,000 labor hours distributed over 4 continuous months and mobilized a multidisciplinary crew exceeding 30 engineers, welders, machinists, electricians, and field technicians. The intervention began with precision disassembly in situ, upper works, revolving frame, and 12 meters long, 60T crawler frames were segmented using hydraulic jacking systems and modular lift beams to maintain structural geometry. Oversized components, boom, 21 meters, 70T, and slew deck structures reaching 90T were transported under controlled load spread protocols to Ferrerosa La Jolla facility, where CNC boring mills, robotic FCAW stations, and magnetic particle inspection benches enabled dimensional recovery and defect elimination. Workshop repairs focused on swing racks, propel gearing, crowd machinery, and dipper-handled journals, remachined to OEM tolerances, and laser-cladded where wear exceeded 0.8 millimeters. Simultaneously, mine site repair cells executed weld buildup of the undercarriage tubs and reinforced A-frames with high-strength, low-alloy consumables, minimizing logistics for ultra-heavy fabrications. All electrical propulsion modules, IGBT drive cabinets, and the temperature-critical MG set were overhauled, thermographically validated, and repotting sealed to IP65. Reassembly followed a critical path schedule with daily P6 progress tracking. Torque verification used calibrated hydraulic wrenches with plus or minus 3% accuracy, and alignment of backlash on the swing circle was set to 1.0 plus or minus 0.2 millimeters. The shovel passed functional load testing at 110% nominal payload, demonstrating recovered performance metrics equal to a new machine. Safety performance was exemplary. 0 recordable incidents, achieved through lockout/tagout, dropped object prevention barriers, and 2,400 man-hours of pre-task risk analysis. The project extends the shovel's service life by a projected 60,000 hours, safeguarding production continuity at the client's open-pit operation. Ferrerosa's field assembly team has commissioned a CAT 6050 FS hydraulic front shovel for a southern Peru copper pit, completing the cold start build in less than 4 weeks. The machine integrates Caterpillar's sealed bottom roller undercarriage, monolithic forged rollers with CAT patented bushings and quad lip seals, eliminating the centralized lube manifold and reducing daily service tasks. Dual 2,500 horsepower engines, altitude tuned for Andean deployment, drive closed-loop hydraulics that deliver rapid 16S dig cycle times even above 4,000 meters. A 26 cubic meters high-penetration bucket fitted with the new CAT CL1 hammerless tooth system optimizes fill factors and accelerates changeouts. Rated payload is 50T per pass, perfectly matched to 250-T Class 793D haul trucks for 4-pass loading. Machine health streams via MineStar Health, while Ferrerosa's on-site CVA ensures parts logistics and 95% planned mechanical availability. The assembly and testing process of the CAT 7495. The largest Caterpillar equipment in Peru, more than 20 meters high, and weighing 1,300 tons when operating shovel at Ferreros for the mining project, begins with a thorough inspection of all components, including the frame, mechanical parts, and electronic systems. Next, the main structure is assembled, incorporating the boom hydraulic systems and ensuring precise alignment and maximum safety standards. The electronic control unit is integrated to manage automated and precise operational functions. The large capacity bucket is installed and calibrated to optimize material handling efficiency. Subsequently, the entire hydraulic and electronic movement systems undergo rigorous testing to confirm stable and safe operation. Finally, the shovel is subjected to a comprehensive final inspection before delivery to the Quellaveco project, ensuring high performance, reliability, and operational safety. Minera Cerro Verde completed post-assembly motion tests on a newly overhauled P&H 4100 XPC electric shovel. The protocol verified crowd, swing, hoist, and propel circuits under no load and 110% overload conditions. Accelerometers on the A-frame and boom confirmed peak swing slew at 3.5 revolutions per minute with his less than or equal to 0.12 grams lateral vibration matching OEM limits. Hoist motors achieved full bucket raise in 9.8s, while crowd rams delivered 1,100 kilonewtons thrust without cavitation. Propel gear cases passed thermal stability, holding oil at 78 degrees Celsius after 30 minutes, tramming on a 5% grade. All PLC interlocks, overspeed relays, and regen grid brakes were validated, clearing the shovel for production service. Drillmex 2016 Mr. 5000 mobile carrier rig is a fully mechanically driven, self-propelled unit engineered for conventional drilling, workover, and well service operations demanding rapid moves and minimal pad footprint. Built on a 5-axle 14x10 chassis rated at 136 TGVW, the carrier is powered by a 600 horsepower Tier 4F diesel linked to an Allison 4700 ORS automatic transmission and 2 drop-box transfer cases, delivering 40 kilonewtons drawbar pull and 22% gradability on unimproved lease roads, while maintaining less than 12 T per axle for permit-free transport across most jurisdictions. Four hydraulic outriggers level the rig to plus or minus 0.25 degrees on 1.5 meters uneven terrain. The triple-section telescopic mast, fabricated from ASTM A514 high-toughness square tubing and ultrasonically inspected full-penetration welds, provides 31 meters clear height and 1,250 kilonewtons static hook load in an 8-line configuration. A hydraulically actuated quick-set subbase unfolds a 6x6 meters working floor, allowing crane-free mast erection in under 15 minutes. The mechanically driven drawworks couples a split-torque gearbox to a 7-groove Liebes drum with a hydrodynamic main brake and band-type auxiliary, delivering 37 meters min-bear drum hoisting at 490 kilonewtons. Top Drive Power Swivel HTD 575 supplies 580 kilowatts continuous power and 47 kilonewtons makeup torque, supported by an integrated pipe handling skate and dual-function iron roughneck for automated breakout/makeup up to 13 3/8 in tubulars. Detachable 40-Fort ISO mud skids carry twin 1,000 horsepower triplex pumps rated 7,500 psi at 1,600 L min each, feeding a 750 barrels 2-tank system with dual linear motion shakers and a 3-cone desander for solids control. Three synchronized 1,250 kVA gensets on a roll-off trailer provide N+1 power redundancy, while a PLC SCADA suite governs drawworks, mud circuits, and safety interlocks. Embedded condition monitoring sensors stream vibration and temperature data via satellite to Drillmex Remote Operations Center, enabling predictive maintenance. Rig down to rolling status averages 6 hours with a 5-person crew, achieving sub-24-hour spud-to-spud moves and cutting well construction costs per foot by roughly 12%.
The Premium Peanut Facility in Douglas, Georgia, is one of the most advanced peanut shelling operations in the world. Designed entirely in 3D and spanning 50 acres, the plant can process over 30 tons of peanuts per hour with high automation and minimal labor. At its core is LMC's precision-engineered machinery, including high-speed shellers, vibratory conveyors, and separation systems. Every component was installed using GPS-guided positioning, ensuring exact alignment and reducing installation time. The layout supports a continuous production flow, from receiving raw peanuts to shelling, cleaning, sorting, and packaging, all controlled by VCAM software, which provides real-time monitoring and traceability. Structural frames were analyzed using finite element modeling to ensure vibration stability and safety, especially for tall shakers and conveyors. Designed for efficiency, the plant uses energy-optimized motors and systems tuned for maximum yield with minimal damage. Premium Peanut represents a bold leap in agro-industrial processing technology. VSL provided advanced technical solutions for the HS2 project, including ground treatment for 38 cross passages and diaphragm wall construction at ventilation shafts. At the Chiltern Tunnel's southern portal, they reinforced the TBM launch area using precise piling and grouting techniques. For the 3.4 kilometers Colne Valley Viaduct, VSL led the erection and post-tensioning of precast segments using a refurbished launching gantry. Custom casting cells produce 2 to 4 meter segments assembled with PL3 corrosion-protected tendons. These structural systems support spans of up to 80 meters, ensuring long-term durability and reducing environmental impact through material reuse and optimized construction methods. Merdeka 118 in Kuala Lumpur, standing at 678.9 meters with 118 stories, is now the world's second tallest building. VSL was tasked with lifting its massive spire using a strand lifting system. The spire was hoisted in 13 stages using 4 strand jacks, each carrying up to 57 tons. Each lift took 2 to 3 hours, guided laterally for stability. Once at the final height, the load was transferred from the jacks to permanent anchors. VSL's expertise ensured a precise, safe lift atop this monumental structure. The Primalus Lab team has successfully installed a custom-engineered Astro-Res observatory station at the University of Milano Bicocca in Italy, delivering a complete, turnkey, astronomical observation solution. This advanced station integrates high-precision components for professional-grade research and education. At its core is the Officina Stellaire RIDK 400 telescope, renowned for its superior optical performance, paired with the 10-micron GM 3000 mount for exceptional tracking accuracy essential in long-exposure astrophotography. The installation process began with site preparation, including precise foundation alignment to ensure vibration-free operation. The Scope Dome 3MV3 dome was then assembled and mounted, followed by integration of the dome rotation and shutter automation systems. The telescope and mount were carefully positioned on a reinforced pier, with millimeter-level calibration to guarantee optical axis alignment. Next, the Eagle remote control and power unit was installed, enabling central management of all devices. The ESATTO robotic focuser was fitted to the optical tube for automated precision focusing, while the Giotto smart flat field generator with Alto cover motor was mounted to streamline calibration and protection. All control systems were networked for seamless remote operation, with cable routing designed to prevent tangling during dome and telescope movement. This custom Astro-Res installation is designed for year-round operation, offering researchers the ability to conduct continuous observational campaigns without manual intervention. The modular architecture allows future upgrades, while the robust integration ensures minimal downtime. By combining cutting-edge optics, automation, and environmental control, the University of Milano Bicocca gains a state-of-the-art research platform capable of supporting both advanced astronomical studies and student training programs. This project reflects commitment to delivering bespoke, high-performance observatory solutions tailored to the needs of modern research institutions. The dual compact observatory station, installed at H-Farm, is a cost-effective yet advanced solution by Primalus Lab for remote space exploration and astronomy education. During installation at H-Farm, the heavy pier was precisely aligned, the Alt-Az mount calibrated, and both optical tubes balanced and configured with their imaging accessories. The Eagle remote control and power management unit was integrated to provide complete off-site operation, from focus adjustments to dome movement. Designed with versatility in mind, it features a dual telescope configuration mounted in parallel on a heavy-duty pier with an alt-az mount. One telescope offers a short focal length for wide-field imaging, while the other provides a long focal length for detailed observations. Both are equipped with ESATTO robotic focusers, Arco rotators, Giotto flat-field generators, and Alto telescope cover motors, ensuring precision, automation, and protection. Each telescope is paired with a dedicated scientific camera, delivering different fields of view to suit various observation tasks. The fully opening dome enables fast telescope movements, essential for tracking not only deep sky objects but also satellites and other objects in Earth orbit. This installation offers H-Farm a robust platform for astronomy education, outreach, and research, blending professional-grade instrumentation with user-friendly remote capabilities, perfect for modern learning environments. The installation of the Bino SSA Observatory Station at the Pampilhosa de Serra Space Observatory, PASO, was carried out with precision to meet the demanding requirements of situational awareness, SSA, and space surveillance and tracking, SST operations. The process began with foundation preparation and pier alignment, ensuring absolute stability for high-precision tracking. The fully opening dome structure was assembled on-site, allowing unobstructed 360-degree sky access and smooth integration with the automated control system. Next, the high slew-speed computerized mount was securely fixed to the pier, followed by careful installation of the twin TI-35 telescopes by Telescopi Italiani, each equipped with high-resolution cameras. The optical systems were aligned to deliver a wide and customizable field of view for space debris tracking and astronomical applications. At the heart of the station are two high-performance telescopes, shown here as the TI-35 by Telescopi Italiani, equipped with sensitive cameras that deliver a large, customizable field of view, ideal for wide sky surveys. The high slew-speed precision computerized mount allows rapid repositioning, enabling the capture of fast-moving satellites and debris across orbits. The observatory features a fully opening dome, ensuring an unobstructed sky view for maximum tracking efficiency. Its imaging train, comprising advanced cameras, motorized filter wheels, and multi-band filters, supports the analysis of different object albedos, aiding in material and size estimation.